Bismillah ar-Rahman ar-Rahim. Dear students, today we deal with quick sort. Quick sort is a very quick sort. Basically, it's called quick sort because it's very quick. It was CAR Hoare. Basically, it was CAR Hoare. Okay, who developed it? And its complexity is basically n log to the base 2n, logarithmic and very fast than what we have seen previously, which has quadratic complexity like your selection sort, insertion sort, and bubble sort. One of the algorithms which we saw, that was the merge sort, which uses the divide and conquer paradigm, and this quick sort also uses the divide and conquer paradigm. What it does is, it is very simple. What it does is, we have the elements. For example, it is some elements, say 9, 10, 5, 6, 4, 20, 3. For example, we got these numbers. We got 1, 2, 3, 4, 5, 6, 7 numbers, 0 to 7, 0, 1, 2, 3, 4, 5 and 6. So we got 0 to 6 as an index of these numbers. If we got another number, say for example I got the number 1 here. Okay, to get it 8 numbers. Now quicksort does what is, first it seeks what's called as a pivot. So a pivot is something you can choose any number, say for example the first element of the array, the last element of the array, or probably what we will do is the mid element of the array as a pivot, and then what we do is we put this pivot in a correct place, and every element lesser than the pivot on the left side, and every element greater than the pivot on the right side. So for example, this time we got a 0 plus 7. So 0, so what pivot, how we calculate pivot is 0 plus 7 divided by 2. That's gonna be 7 divided by 2, and that's gonna be 3. So my pivot happens to be this element, and I set my low to this, and I will set my high to this. Okay, and in the beginning when I call this quick sort function, I got a quick sort function. When I call it, I send it as 0. Firstly the array, maybe the name of the array is AR, and the first element 0, and the last index, that is 7, n minus 1, that's going to be 7. But later on this will change, so I will catch them in the low and in the high. So 7 will go into the high, 0 will go into the low, right, when I catch it in the actual function definition. So low stays here, high stays here. Now what I do is I go on incrementing the low, and I go on decrementing the high. I will increment the low only if I find this 9, for example, is greater than this 6. Yes, it is. So I should not increment the low. So I should increment the low only if I find some element which is lesser. If this element is lesser than 6, I should go forward, because this lesser element should be there. If it is greater, it should be swapped on this side of the 6. So I don't need to increment. So low is 9, so I stay there. So I'm staying it at a high. When after I see the low, I see the high. High is 1. Is 1 lesser than the 4? Yes, it is. So I should not increment. Only cases if 1 is greater than the 4, I should go on incrementing, right? So this is lesser, or 4 is greater than the 1, I should not increment, and high stays here, low stays here. What I do is I swap them. I swap these guys. Okay, okay, why is it not going down? Yes, I should swap these guys, for example 9 and 1, so we will get the things like this. Get the pen, some problem happened. So I should swap these guys here, right? I should put up the 1 here, then 10, then 5, then 6, then 4, then 20, then 3 and 1. And simultaneously what I do is I increment my low and high. Okay, I do what? I increment my low and high. So my low will become here, and mind you, this is now the low, and this is now the high. Okay, and my initial value 0, and the initial low, that is 0, that stays here, and initial high 7, that stays here. The high, sorry, here, not high, is here. that so I don't know what to call it. So say let it call me L, and I call it I let it call it H as high and L as low. So whatever we have used in the program. Okay, now go on. Now low goes forward. Now again check the low with the mid element, the pivot, and I'm seeing low. Yeah, it is it's greater, so I should not increment low, and 3 is lesser, I should not decrement the high, so I should swap them together. I say 1, I should put up the 3 here, 5, 6, 4, 20 and 10 here, and 1 goes here. Okay, my initial high is this, my initial low is this. That doesn't change, but the high and the low has changed. Now low has gone to this position 5 and high has gone to the position 10. Is it 10 or 20? Yeah, high is here, right? Okay, again I'm checking, is this guy greater than 6? But it is not, it's lesser, so I should increment it. So low is low plus 1, low will become to this, right? Not this. And high, is high greater than is high I meant to say greater than 6? Yes it is, so increment the high, high goes here, right? Not this. Again this will run in a loop. So is this is 4, is this 4 less than the greater than the 6? No, it is not, so stay high there, low is here, and swap them together unless low is not less than, unless low is, until, I mean to say low, while low is less than equal to high, you're gonna swap them. So 4 comes here, 6 comes here, 5, 3, 1, 20, 10 and 1, and now low has gone here and high has gone here. So when the low has gone here, high has gone here, they cross together, you'll stop. That means you have put your 6 in the correct place where it should have been. This is gone in the correct place. So that means this 6 is sorted. This pivot is sorted. So what you want to do is now sort these guys and sort these guys, same procedure. Now what do you do with that? How you do this? Okay, wait a second. Now what we do, we will check first, is this because we have to, up to certain limit we have to do this, right? It's not going down, what's happening? Okay, what will happen here is this is my initial low and this is my initial high, that stays there, but I have to see, now low is gone here, high is gone here. Now I have to see this high, is this high gone to the all the way to the low? But it is not. So I mean this is, there is some elements here which you're gonna sort, this left sub-array. So I will call the quick sort and send the array AR and send this low as a low, my 0, and send this mid that high minus 1, that is this high. Okay, and similarly I'm gonna call, after this I'm gonna call quick sort AR, and I'm gonna send the low, right? Low is happen to be here, which is this element, right? In fact low must have incremented one step, and so I will send low and I will send the high H, but H, right? The initial high. If condition, if they have not crossed it, if this low has not crossed its edge, and condition here if this low is not crossed. So this will do some recursively the same thing what we did here on the top, and until this high has reached the 1, this is then the single element hits, so it comes back. And no need to merge here, because in the merge, so we started, after that we started merging. We don't have to merge because they are already being, this is in place sorting. So we are already, actually we put the 6 in the correct place. Similarly in this case we put the 5 in the correct place, and then in these we put the 1, 3 and so on in the correct place, and so on this side. So ultimately we got the sorted array. So if you see the program here, in the main I'm saying the value, this is my array name of size 100. Print of unsorted list is as follows. For I is 0, I is less than 10, I plus plus. What I'm going to do is I use a random function. The rand function actually generates any random number from 0 up to the rand max, and rand max is machine dependent, and its maximum times in 32 machines, it's some int size, that's 32767. Okay, to generate that number and divide it by 100, and the remainder always be, if you divide by 100, remainder will be 2-digit number. So for this case it will give me up to the 100. If you %10 100, so it will be 0 up to 99 the number. So that will go into the value of I, and so on. So it initializes the array. Then I call the quick sort, I send the initial values, that's 0 and 9, okay, because I am putting up here up to 10, 0 up to I'm getting only this many number. So actually I should have done here, got the n, how many numbers do you wanna, and then go up to n. So I will change a little bit. I will say printf, not here but here, printf \n, how many numbers, and I will scan of that into the percentage d, will close comma, ampersand n, and close it. So I need n also here, so I need n here. I will say comma n, and now you're gonna say unsorted list, but you have to run up to less than n, okay, verify, and 0 up to n. So you send the n, you send this n, maybe the n is now 10 or 20 or whatever you like, okay. Sorted list, and then when you're done quick sort, you come back and give the sorted list. So again I go to up to n, okay. Okay, so when it calls the quick sort, I'm setting the 0 and n. The 0 is the initial low and this n is the initial high. And if you see the quick sort here, and this will get, this is my array, this is first, so I will copy the 0 in the first and copy the last, the n of the, n minus 1 element to the last. Then I need the low and high, which I was talking about, and a pivot and a temp, wherein which will use it for the, what's that called, swapping. So low, I will keep the low as the first and high as the last. Then I say pivot, I create the pivot as the mid element, and then I'm gonna do while loop, and I will run while up to low is less than equal to high. If low and high is crossed, we are done with the first round, right? So while array of low is less than pivot, okay, you're gonna say low plus plus, because on the pivot's left side should be all lesser elements. So if the low in the array I'm talking about, element, the first element of the array this time, because low will be 0, is this less than pivot, so it should be there, we should not change with it, so we should increment the low plus plus. Similarly, if array of high is greater than equal to pivot, if the any element on the right side of the pivot, because if the high is the last element, if the that's going to be greater than pivot, so I should decrement the high because that should be there. So what is this trying to see is it's trying to seek the first element is greater than the pivot on the left side. This is trying to seek the element lesser than the pivot on the right side, and then we're going to swap them. Condition, if low is less than equal to high, so that means it's not the same element, right? If low is less than equal to high, so then we're going to swap them, as you know, and increment the low and decrement the high. So low is coming this way, high is coming that way, you know, yeah, as we saw here, the high is coming this way and low is coming this way. So it's trying to seek on this element anything element is greater than this pivot, and in this side we're trying to seek anything element which is lesser than the pivot, so we should swap them together, okay. Let me swap them here. When we are done with the swapping at all, right, we are done with the swapping here, and this while loop runs does what is keeps the pivot in the correct place and continuously swaps elements together unless the left side of the pivot is lesser than the pivot and the right side of the pivot is greater than the pivot. But we're not done. We have got only 2 sub-arrays. So that's why we're gonna do what? We're gonna recursively do things for the left sub-array and the right sub-array. How we do that? We say first, if first is less than high, okay, the condition is that no, I call it first, right? I will call it first now. We call it first is the 0, and I'm coming up, the high is coming up this way. So high and first, they should not cross. If they have crossed, that means we have done with all the elements, right? Similarly, on the low and the last, they should not cross. That means we are done. If they are lesser, then we should go for recursive again, quick sorting and sending the left subarray and right subarray. So I'm saying array first and high. I'm sending first and high because high is gone to the pivots 1 plus, and last is gone to the pivots 1 more. Okay, low. I'm sending the low because low is pivot plus 1. Is it? And this high is pivot minus 1. So I got a first sub array here. First is 0, high is pivot minus 1, and low is actually pivot plus 1 and last. Okay, so like we did a merge sort, mid plus 1 and last. Here we do 0 and mid minus 1. That's the same sort of thing, and recursively do it, and we are done. So if you run it, if we run it, we got how many numbers? So we say, for example, 20 numbers, and random number generation function will generate the random numbers, 2-digit numbers, and then it's sorted. If you see, it's sorted. Okay, we got a couple of zeros here, one zero is here, because we got a couple of zeros here. I'm not finding another zero. I don't know why is there another zero. Okay, so it's sorting it in perfect fashion, right? Okay, and that's it.